Circular Motion 2. Introduction. You have learned in Circular Motion 1 that you can have constant speed and still be accelerating all the time. Of course, if you were a roller coaster designer, you would need to be able to do the calculations to be certain that your passengers would make it round the loop. In this lesson, you will find out how to do such calculations. In this lesson, you will learn what is meant by centripetal acceleration, learn how to calculate centripetal acceleration, understand how the equation for centripetal acceleration is derived, and how radians are helpful in its derivation. You are at the fun fair. Click play button to start the big wheel. When does the wheel have uniform circular motion? Answer: when its speed is constant. What quantities will be the same for the occupants of each car when the wheel is rotating with uniform circular motion? Answer: speed, radius of motion, kinetic energy, and magnitudes of vector quantities such as velocity, angular velocity, acceleration, and force. What quantities will be different for each car when the wheel has uniform circular motion? Answer: the vector quantities, velocity, angular velocity, acceleration, momentum, and force have different directions.
So this consists all of them are vector quantity, and all of them consist of the direction. So if in the circular motion, the direction always change, this means that the velocity, angular velocity, acceleration, momentum, and the force are always changed. The change because of the change in direction.
Click pause button to pause the motion at any point. With the motion paused, you can click on different cars to see how the motion is different from each one.
So this one actually show that this arrow show this direction, yeah. So for this cut, so how about if the car in this direction? You see, in each different point, the velocity are always change. So like that. You see, the magnitude are always equal. This direction always 90 degree to the circle. This one 90 degree is the same direction. This one 90 degree to the circle, tangent to the circle.
Click play button again, then click reverse button to stop the wheel.
So stop, you see that the speed reduced, right?
Click load passengers and then play button.
Load passenger, this means that somebody go in, load that we
load. The motion circular but not uniform.
So we load it, that means there will be the acceleration and deceleration. You see the size increase and reduce, increase and reduce, the speed increase, decrease, increase, decrease, increase, this means start moving, reduce because want to stop to load the passenger.
Answer: when the wheel is speeding up or slowing down. Click load passengers button and then play button to start the big wheel.
So now the relationship, the speed increase and reduce. That means that there will be the velocity increase and decrease, but the direction change. once there will be a centripetal force. How is the centripetal force? Always point to center, yeah. Okay, and the tangent acceleration, because now it's moved fast. Okay, increase the speed and reduce the speed. So with the angular acceleration.
Watch the two acceleration boxes as the wheel turns. How would you describe the direction of the tangential acceleration?
Tangential acceleration is an object moving in a circular path directed at the tangent of the curve. Just some move with an angular velocity. If there is a change in the angular velocity, that means that there will be an angular acceleration. The acceleration is circular motion.
Answer: along a tangent to the circle. Now watch the tangential acceleration and the velocity boxes. Do they have the same direction all the time?
Okay, so now we notice that is it they have the same direction? No, there will be the centripetal acceleration and the velocity always in 90 degrees.
Answer: no. They have the same direction when speeding up and opposite direction when slowing down.
Okay, so now slowing down, right? We notice that the what's that, the decrease, right, the speed. So come again, let's see, is it okay, something. Okay, still does. Okay, now when the speed increase, okay, so speed increase the tangential acceleration. Okay, tangential acceleration and the velocity always in the opposite direction. Okay, so now what happened? When down, okay, this means speed reduced, they will be the same direction. Okay, they will be the same direction when reduced. When increased in opposite direction.
Click reverse button to stop the wheel and click load passengers button again. So there are no passengers on the big wheel.
Now there's no passenger.
Now click play button to start the big wheel again.
That means. Okay, now there's no passenger. No passenger, that means that it moves with a constant speed, constant velocity. That means that constant centripetal acceleration, but there's no tangential acceleration. No tangential acceleration, that means that no angular acceleration. Okay. Okay, teacher, why reduce in the same direction but increase in the opposite direction? Okay, increase in the opposite direction because there is a change of the speed. Okay, change of the speed and then circular motion. Okay, not same with the linear motion. There will be a little bit difference. Okay. When there is the increase in the angle, remember this thing. When there is the increasing in the speed, that means that the direction of the angular acceleration is opposite. That's all. Okay. If there will be a reduce, they will be in the same direction. Okay.
Look at the tangential acceleration box now. What happens to the tangential acceleration when the speed is constant? Answer is 0.
So this means zero acceleration.
Explore different motions of the wheel, remembering that you can click pause and then click different cars for different viewpoints.
So that means that 90-degree difference, okay, always tangent, okay, always tangent, but at any car, if the speed is constant, this means that the tangential acceleration will be 0.
How does the magnitude of the centripetal acceleration vector change compared to the velocity vector?
Centripetal acceleration always point to the center. The acceleration always point to the center. Acceleration of object in circular path directed towards the center of the circle, which is perpendicular to the direction of the motion, causing change in direction, not change in speed. Okay, because of the centripetal force, the centripetal acceleration cause the object change in the direction, but not change in the speed.
Answer. The magnitude of the centripetal acceleration is greater when the magnitude of the velocity is greater. How does the direction of the centripetal acceleration vector change compared to the velocity vector? Answer. They are always perpendicular. The sentences below describe what is happening when circular motion is uniform.
When the
What
circular
are the missing
motion,
words?
when the circular motion is uniform.
Blank. Acceleration is equal to 0.
So what is that? So that is the tangential acceleration.
Answer. Tangential. The magnitude of blank acceleration depends on the magnitude of the blank.
What is that? That is the
centripetal velocity.
so centripetal acceleration depends on the velocity. If no velocity, no centripetal acceleration.
The direction of centripetal acceleration is blank. So velocity
Is 90 degree.
Answer. Perpendicular. You have seen that the magnitude of the centripetal acceleration depends on the magnitude of the velocity. What is another name for the magnitude of velocity?
Okay, now we look at the centripetal acceleration, A. The A is always point to the center, yeah, point to the center, yeah. So the formula for the centripetal acceleration is equal to V squared over R.
Answer. Speed. The equation in the small box gives the actual relationship between centripetal acceleration and speed. You will see how this equation is derived in activity 2. Use the sliders to set radius and speed to any values that you want.
Let's say we use 1, 1.
Now click play button to set the ball moving.
So you see the speed, okay? If I increase the radius, that means just now it's very fast, right? Okay, because the distance is smaller. When the radius become bigger, so it becomes slower. Okay, just now the speed still same. Just this is the linear speed, the tangential speed. But you notice or not, it becomes slower. Okay, so if I increase the speed, you see, okay, there will be a velocity. If this one, okay, you see, once the radius decrease big, we can see the velocity change. We can see the centripetal action. But once I reduce the what happened? You look at the centripetal acceleration. Starting with 3.2, increase to 16.
Notice that the magnitude of the centripetal acceleration is calculated for you in the centripetal acceleration use the equation A equals v squared over r to check that you get the same value for centripetal acceleration.
Okay, Yongwei, centripetal acceleration is used to make the object always move in circular motion. Okay.
Click reverse button and use the sliders to try some other values of radius and speed.
Okay, we already tried.
Why does the magnitude of the centripetal acceleration change so much?
Why it's changed so much? Because
Answer: because it depends on the square of the speed.
so because the speed A is directly proportional to the v squared. A is inversely proportional to r.
Speed is the distance traveled per second. You know that any distance on a circle equals r theta, where theta is the angle in radians and r is the radius. You have met omega, the angular velocity. What equation links the speed v and the angular velocity omega? Answer: v equals r omega.
So we use that v is equal to r omega. This is the formula for the linear speed. The speed, yeah, tangential speed equal to r omega. Omega is the angular velocity.
Then, what is the equation for centripetal acceleration in terms of omega and r instead of v and r? Answer: A equals omega squared r. This time, you can start the motion gradually. Use the sliders to set radius, speed, and tangential acceleration, and click play button to set the ball moving.
So we notice that tangential acceleration just when it start move only. Okay, so when it's starting move. Okay, after that, when let's say I increase the radius. Okay, again, what happened? Once I increase the radius and start. Okay. What happened if the tangential acceleration increase? Okay, tangential increase, speed increase, everything we set to maximum.
You can click pause button to pause and reverse button to stop the motion.
So from here, no matter how, the A is always directly proportional to the V squared, and A is always inversely proportional to the R. Okay, so as a conclusion, we can set that, okay, if an object moving in a circle,
Summary: if an object moving in a circle is speeding up, then it will have a tangential acceleration in the same direction as the velocity. If an object moving in a circle is slowing down, then it will have a tangential acceleration in the opposite direction to the velocity. The tangential acceleration is equal to 0 when speed is constant. Circular motion is uniform. An object moving in a circle always has a centripetal acceleration. The centripetal acceleration is directed to the center of the circle and perpendicular to the velocity. The velocity v and angular velocity omega are related by v equals r omega, where r is the radius of the circle. The magnitude of the centripetal acceleration is given by A equals v squared over r. The magnitude of the centripetal acceleration in terms of angular velocity is given by A equals omega squared r.
Okay, sorry, just now there's one statement I need to make the correction. So when the is moving, okay, when the speed of the circular motion increase, okay, this means that the tangential acceleration, okay, in the same direction, not opposite direction. Okay.
Here you can see a ball moving in a circle. You are going to consider velocity change. Click velocity change button. Two velocity vectors and the vector which represents the change in velocity appear. Click reset button and try again.
Okay, so this means it moved from anywhere. That means they have V1, V2, where this will be the change of the velocity.
Notice the vectors are always taken from the same point on the circle. How would you write an equation for centripetal acceleration? Answer: alpha equals delta V over delta T.
dv, delta V over delta T.
This time, you will get a bit more information when you click velocity change. Click velocity change.
So now there is a big change. So how is it?
What is the angle between V1 and V2? Answer: 2 alpha.
So one circular, that means that from A to C. So there's a velocity change in V1 and V2. So the angle is 2 alpha, yeah. So the, okay, that's easiest we said that is the angle from the difference between V1 and V2.
If the magnitude of V1 and V2 is simply V, remember, this is constant for uniform circular motion. What would be an equation for delta V? Answer: 2V sine alpha.
So that means that it will be 2V sine alpha.
Here you will learn how the equation for centripetal acceleration is derived. Drag and drop the correct boxes at the bottom of the screen to make the formula to find the distance round a circle.
Just now the distance, okay, round the circle, that will be 2. Just now is, okay, distance for one round, okay. So okay, ladies and gentlemen, look at the speed. What is the distance around the circle? Distance around the circle will be equal to 2 pi r, one circumference. Okay, and then how about the speed? Speed is v. So to get the time, time is equal to 2 pi r, total distance for one circle, over the speed. It will be equal to time taken.
Now drag and drop the box with the letter that represents speed.
So this is for the speed, yeah.
Finally, drag and drop the correct boxes to make the equation to find the time to go all the way around a circle. You may notice that an incorrect box will not be accepted, so you cannot go wrong. However, you should always try to work out, rather than guess, the correct box before dragging and dropping. Now select Angle button and complete the screen by dragging and dropping the correct boxes from the bottom of the screen.
Okay, how about the angle? For angle just now, from V1 to V2, there is 2 alpha just now, the angle. Okay, so fraction between the circle travel between A and C, between AC, yeah? AC, the distance and the angle will be 2 alpha. So that means fraction, that means total is equal to 2 pi. Okay, how about the time taken? Okay, the time taken for the, okay, between A and C, it will be, okay, how about the time? Time will be equal to 2 pi r. 2 pi r over v will be the time taken for the motion times with the portion. That means how is the, okay, ratio of the angle. So it's 2 alpha, that's the distance moved, over 1 circle is equal to 2 pi. So let's, okay, rearrange again. So 2 pi and 2 pi cancel each other. So that means we will have r. Okay, so that means 2 angle alpha r over 2 pi cancel, that means left v. Okay, and last, how about the acceleration? Acceleration will be equal to 2 sin alpha times with the speed. So how about the delta t? Delta t will be equal to 2 alpha times with r over the velocity. When substitute delta v over delta t, we get that it will be 2 sin alpha v divided by 2 alpha r divided by v, right? Divided by v, so it becomes times v. So that means at the end, cancel the 2, we get that sin v squared over r alpha. There will be the acceleration, angular acceleration. Okay. Okay. So this means, as a conclusion,
the centripetal acceleration can be derived as A equals v squared over r, or A equals omega squared r.
So from here, if an object is moving in a circle, is speeding up, then it will have a tangential acceleration in the same direction as the velocity. If an object is moving in a circle, slowing down, so then it will have a tangential acceleration in the opposite direction of the velocity. The tangential acceleration is equal to 0 when speed is constant, where is in the circular, its circular motion is uniform. An object in a circle always has a centripetal acceleration, and the centripetal acceleration is directed to the center of the circle and perpendicular to the velocity. The velocity v and the angular velocity omega are related with by a formula v equal to r omega, where r is the radius of the circle. The magnitude of the centripetal acceleration is given by a equal to v squared over r, and the magnitude of the centripetal acceleration in terms of angular velocity is given by a equal to omega squared r. And the centripetal acceleration can be derived as A equal to V squared over R or A equal to omega squared R. Ladies and gentlemen, that's all other formula we will use to solve the problems later. So that's all for today's lesson. See you on next lesson. Thank you very much and see you.